Hello students, today I am taking one more sum which is related to the types of functions. The problem is show that the greatest integer function given by fx equals to x and then the big bracket is neither 1 1 nor on 2. I have already explained you dear students that 1 1 means different element have different image and on 2 means every element of the second set have some pre-image in the first set. Every element of this is having relation with different element that we have to prove, and every element of the second set codomain is having some or other image. That is the meaning of 1 1 and on 2. But we have to prove here that this particular function is neither following this relation, this particular function, not following this particular function. Here, as I told you, and you have read in the 11th class, what is the meaning of greatest integer function? The meaning is, if you put x in a big bracket, then it means the greatest integer which is less than or equal to x. I am taking the example and then I am explaining you. Now, let x1 is 3.1 and x2 is 3.9. Yes? Now, according to the definition of the greatest integer function, it is fx is this. It means it denotes the greatest integer which is less than or equals to 1. So, what will be the value of 3.1? The value of 3.1 is 3.1 and the big bracket. It means it is 3. And if I write here 3.9, you can put small bracket also here. Then it is 3.9 and still the answer will be 3 only. Now you see 3.1 and 3.9, these two are not equal, but this part is equal. That is x1 is not equal to x2, but fx1 is equal to fx2. So we can say the different element have the same image. So it will not be. Therefore, it is not 1 1. So this function is not 1 1. Now I am coming to the onto function. If you study nicely, the x greatest integer function, what is less than or equals to greatest integer less than or equals to x. It means what will be the range? The range of fx will be z, that is set of integers, and that is not equal to the real number. So there will be many numbers in the second R, that is codomain, which will not have any pre-image. Like if I take a number 2.5, now 2.5 will not come here, means it will not be in the range, but it is still a real number. So many real numbers will left unattended, they will not have any pre-image. So in that way we can say that it is not onto also. So greatest integer function is neither 1 1 nor onto. I hope it is clear to you. Now I am taking the second problem. Now second problem for today is show that modulus function, real number to real number, given by fx equals to modulus x, absolute x, is neither 1 1 nor 1. Now look here, I am explaining. Suppose x1, if I take x1 equals to 2 and x2 equals to minus 2, then what is fx1? It is f2. And f2 is modulus of 2, that is 2. If I take fx2, it is f minus 2. So it is minus 2 and the modulus will be 2. Now in this, what you observe? You observe that fx1 is equal to fx2 because f2 is equal to f minus 2. But, a big but x1 is not equal to x2 because 2 is not equal to minus 2. So we can say here that two different elements have the same image. Two different elements have the same image, means their image is equal but the values are not equal. So in that case it will not be 1, 1. You see this part, this one, that fx1 is equal to fx2 but x1 is not equal to x2. So we can say that the modulus function is not 1, 1. That is, different elements have same image. So in that case it will not be 1. And for onto, you see there is an element minus 2 or any element minus 4. This element belongs to real number, belongs to this real number. Yes, but it will not be the value of any fx will not be equal to minus 4. If you put any value here, it will never be minus 4. It means there will be many elements in the second set which will be unattended. So we can say here that the range of this function will not be equal to codomain. If the range is equal to codomain, then it is onto function, but this will not be onto. The reason is that the range of this function will be only the positive number and negative numbers will be left unattended. That is, there are many elements in this which will not have any pre-image. So in that case we say that it is not onto, because I already told you that 1, 1 means different element have different image and onto means every element of the second set is having some or other image in the first set. So we can say that the modulus function is also neither 1, 1 nor onto. Clear? This part. Thank you.